Cái này quan trọng, giới hạn kiểm tra giới kỷ là không có giới hạn. Có muốn giới hạn không ạ? Có muốn giới hạn không ạ? Chương 1, chương 2 của Mechanics. Và Thermodynamics thì chỉ tới hết định luật 1. Dễ quá đúng không ạ? Phần còn lại để còn cho final exam chứ. Mechanics là chỉ chương 1, 2 này. Thermodynamics là chỉ phần 1, 2 tới first law thermodynamics. Phần nào dễ hơn ạ? Phần nào dễ hơn ạ? Thermodynamics dễ hơn ạ? Rất tốt ạ. Bởi vì tỷ lệ mỗi năm là thermodynamics trượt nhiều hơn. Năm nay là cố gắng nhé. Cố gắng thermodynamics đỗ hết. Đã yếu sinh rồi thì không được yếu lý. Hiểu không ạ? Đặc biệt là hai môn đấy phải giỏi 1 trong 2. Không thể đi ra ngoài mà lại bảo là sinh viên này yếu sinh lý được. We start again. Mỗi bạn một tờ giấy ạ, mỗi bạn một cái bút ạ. Riêng cô Mai Chi là cô có cái gì viết đấy ạ. Rồi. Biết là cô phải viết trong cùng một đấy. Okay, we continue the last session. I'm sorry, the last part of this session. We will verify. We will try to establish the relationship between the temperature, the pressure, and what we call the root mean squared speed. The root mean squared speed. Vào rồi, wake up. Cái bọn 247 chắc là phải trả tiền cho mình khá đấy, tiền quảng cáo. Wake up 247. Wake up. Good. So you have something to write. Yeah? Okay, we try to establish it. Now we consider this problem. We have a cubic box. This one. Yeah. The length of each edge is L. Okay. Here, please look at here. We consider a molecule of mass M. Good. And a velocity. It has a velocity. Of course, when we talk about the velocity, we should take into account the direction of the movement also. That's why we put it in the vector. Rồi, các bạn tập trung được chưa? Ok, không tiếng gì dầm nữa nhé. And vector. Now, we know that the area of one side is L squared, right? Now, this molecule is about to collide with this wall, right? We want to establish the relationship between the pressure, because we know when there's a collision to this wall, it will apply a pressure on this wall. This molecule will apply a pressure on this wall. A temperature, okay, and the speed of that molecule. We want to establish this relationship. Now, for the time being, we ignore the collisions of the molecule. Okay? We consider only elastic collisions with the walls. So you know, in an elastic collision, the kinetic energy is conserved. Good. We try to find the connection between the pressure exerted by the gas on the walls and the speed of the molecules. We start to do it. Yeah. The first thing we can realize that when this molecule, my molecule, collides with this wall, okay, with this wall. So the only component of its velocity that is changed is the x component. Let's say the x component. Yeah. So it collides to this. So only the x component is changed. Not this one. Yeah, not that one. Good. And because we consider elastic collision, then we can say that that component is reserved. Okay? Elastic collision. Then the kinetic energy is conserved. When it collides here, it will be bounced again. Now we can write. Please start to write the change in the particles momentum. This is kinetics. This is mechanics. I mean, yeah, tôi đang sử dụng mechanics đây ạ. This one you know, right? The change in the particles momentum is actually the final momentum minus the initial momentum. Cái này nó là cái lỗi tôi không hiểu sao, rất nhiều lần tôi đã sửa cái này rồi, nhưng mỗi lần tôi xếp lại nó lại trở thành chữ x to. Chờ tới một tí tôi copy lại cho các cậu đỡ nhầm. Sao để cho cái thằng của nợ này nó bay lên nhỉ?
Đây nữa.
Ok, bay lên nào, em bay lên rời nào. Cả cái Vx này nữa nha. Nên là đôi khi là cái slide này năm ngoái cũng phải sửa, năm nay lại vẫn phải sửa. Good, this is the way. So this is the final momentum.
Not save here.
Do you agree with me?
Not available. Nãy mà mình học kéo các thầy ra tát.
Đến đi ạ. Rồi, ok.
Để có tát được cái máy tính các thầy.
Good. So, if we take only the value, then the change in the momentum following the vertical axis, the x-axis or x-axis, is 2mvx, right? Good. Mechanics, you should understand this here. Are you able to rewrite it? You have to rewrite it. Good. Now, we consider the time between collisions. Okay? I call it delta t. Good. It's actually the time the molecules take to travel to the opposite wall and back again. So, the time to travel to the opposite wall and back again, it will make a distance of 2L. Here, from here to here and back again 3 hours at a speed Vx. Then we should be able to write delta t equal 2r over v, right? You agree? I try to be slowly, then we establish it together. Is it okay? I continue?
Yes.
Then the average rate at which momentum is delivered to this wall, yeah, by this single molecule, by only one molecule. Yeah, the average rate can be calculated by this one. So we replace the change in momentum here. We replace delta t. Is it okay? We should have this expression mvx squared over L. Please rewrite it. Ôi, tay thì cầm bánh bao, mồm thì nhai nhồm nhoàm này, lấy đâu ra tay mà viết bài. Thanh niên, thôi kết thúc đi, em viết đi. Không tí là lost đấy. Okay, I continue.
Yes.
Now we apply the Newton's law. I use only mechanics to explain it. We apply the Newton's law, right? The Newton's law. What do we have? Yeah, we apply the Newton's laws. And we also know that the pressure is actually the total force of all molecules. Here we consider only one molecule. But of course, in our box we have more molecules. And the pressure is actually the total force of all molecules at different speeds also. Each molecule has a speed. We have a lot of molecules and each molecule apply one force onto the wall. The pressure is actually the total force applied to an area. The area, if we consider this area only, we have the area of L squared, right? And the total force here, we can apply the Newton's second law. Then we rewrite it. Good. The pressure is actually the force of every molecule over this area. Then, is it okay? We have to sum up the force of each molecule. I back it a little bit here. Here we already able to establish this. Okay, the average rate at which momentum is delivered to this wall. Good. This is actually the force. Now we apply this. Okay, mv squared L. Here, you see, each time we apply. Cái số 2 nó là ở trên đây các bạn nhé.
À thì
Hiểu không? Năm nào tôi cũng phải sửa cái phần này. Tôi đang chưa hiểu là vì sao. Nó là dấu bình phương.
thì
Nhưng mà
không hỗ trợ.
cái máy thần thánh của tớ nó cứ hiện như thế.
Máy thầy không hỗ trợ.
Thử nhé, thử lại nhé. Ta tắt cái này đi nhé. Mở ra. 2 là bình phương đấy các bạn ạ.
Bí luôn.
Đây các bạn thấy chưa? Tôi vừa sửa nhá, tôi vừa xếp lại nhá,
Thì
nó vẫn đi xuống dưới.
máy tí là không hỗ trợ. Vì hỗ trợ rồi.
Được chưa? Rất là khó hiểu.
Cái nó xếp mà.
Is it okay?
Bây giờ ngay cái mà.
Now we can rewrite this formula and it will become this. You still with me? Good? Okay, it's good that some still with me. Now we have this expression. This expression. We can still simplify this expression. Now we replace n, okay, equal n times na. Good. We should be able to rewrite this one. Is it okay? Here we replace this, equal this. The average speed, this is the average speed. Still okay? Then we should have the final expression. Somehow gì? Đấy. Feeling lost? Is it okay? Chưa hiểu ạ, chưa hiểu về viết lại đi ạ.
Này sẽ chết đấy.
Tới phần nào chưa hiểu ạ? Phần này ok chưa ạ? Phần này ok chưa ạ? Phần này ok chưa ạ? Chưa. Phần nào chưa ok nhỉ? Hay là tớ làm nhầm một chỗ nào? Cái gì không ok ạ? Đây ta có n lần của thằng này đúng không ạ? Ta thay bằng một thằng average ạ, thì ta phải tôi có nhầm một cái phần nào không ạ? Now we continue. That's why I say you have to write it down and then step by step. Now we replace again. This one equal the molar mass and the 3L here is actually the volume of this cube. Finally, we should have this equation. Okay, so this is the pressure, this is the volume of the cube, here the number of mole, the molar mass, and here this is the average speed. Is it okay? We should be able to have this at the end. If you still do not understand, please take on the slides, rewrite it at home, okay? Step by step. But we should have this one at the end. Now, for any molecules, we know that the speed can be decomposed to three, not only one, but to three components. So the component over x, y, and z, not only one, right? Then, and because our molecules are moving randomly in all directions, we should have this one. We should have this one. They are all moving in random directions. So we should have this one. This should be equal this one, should be equal this one, should be 1/3 of the final speed. Then what do we have? Are you able to rewrite it? That's why I say if you do not have the notebook, if you do not follow, you will be lost. If you just look at the slide. Then we should be able to write the pressure. Now we use the real speed, not only the speed along the x direction, but the speed along all the directions. So you see the difference here, right? Yeah, the difference is only here. We replace Vx here. Now we consider the random movements in all directions. Then we should have this pressure, expression of this pressure. Until here, we should have You still with me? Vẫn còn ở đấy chưa? Chưa lên cung trăng chưa? Cứ step by step nha. Tới đây ok chưa? Good. Bao nhiêu bạn còn follow ạ? Rồi. Còn ông tướng này là bỏ cuộc rồi đấy. Không. Ông tướng này này, bỏ cuộc chưa? Sorry. sorry. Sao không? Now we continue. This one we call it the root mean square speed. So you see, squared speed. Actually the average speed squared. And we take the root. Okay? That's why we call it the root mean squared speed. Root mean squared speed. Once we call it root mean squared speed, we replace it. And for the pressure, it will become this one. Is it okay? Now, we combine with the ideal gas law. PV equal nRT, right? PV equal nRT, we replace this one. We should have an expression of the root mean squared speed. And this is what you can remember from now on. But I don't want you to just remember only this formula. You do not know where does it come from. With this, you can relate, okay, the pressure, with the speed, and here the temperature with the speed. Yeah, any question? No? Is it okay to here? You should be able to remember these two simple, let's say, simple expressions of pressure and root mean squared. But I want you to know, where does it come from? Where does it come from? By establishing step and step. Good. formula tells us a very interesting thing. It tells us how the pressure of the gas, you remember that the pressure of the gas is purely a macroscopic property. Yeah. How a pure macroscopic property depends on the speed of the molecules. This one is actually a purely the microscopic quantity. So you remember at the beginning, I told you that the kinetic theory of gases is to relate the macroscopic world and microscopic world for that reason. Okay, and here, the root mean square speed is just one way for us to calculate, to imagine, to verify, to use. We know that this is one kind of average speed. And when we talk about average speed of molecules, we know that there are molecules that will move faster. There are molecules will move slower. Okay? We move faster. And there are molecules will move slower. Then later on we can consider also how many percent, not this part, how many percent of our molecules will have speed faster than the root mean squared speed. How many molecules, how many percent of the molecules will have speeds lower than that kind of speed. But this is for the next part. Now I invite you to do a very small exercise for you to understand a little bit better the average speed and the root mean squared speed. When we say only the average speed, of course we know how to calculate it, right? The average is actually the sum of everything divided by the number of that molecule, for example. The root mean square speed actually is calculated differently. Here I give you 5 numbers. So I have 5, 11, 32, 67, 89. What is the value, the average value of these numbers? 41, right? 41, good. What is the root mean squared value? What is the root mean squared value? So the root mean squared value is actually calculated by this one. So you square each value first. You square each value. Then you calculated the sum. Okay? You divide by the number. Okay? Then you take the root. So we have the root mean squared value. You see there's a big difference between the average, normal average, and the root mean squared average, root mean squared. Good? Okay. Now we come back to the question of kinetic energy. What you have seen during the mechanics part, we try to answer where does it come from. That kind of energy, okay? We have the kinetic energy. Or more precisely, we have the translational kinetic energy. Translational kinetic energy. Kinetic energy mà chỉ theo một chiều thẳng đấy. Translation of kinetic energy. Where does it come from? Now, once again, we consider single molecule. Single molecule of an ideal gas. And this molecule will collide with other molecules. During the collision, the speed will be changed. This is the problem that we see a lot during the tutorial class with the particle mechanics. Am I right? Then, the kinetic energy at any constant can be written as K equal half mv squared, right? Good. Now, if we replace this with the average speed of all of our molecules, it will have a average speed, right? Average speed. Average speed, if we take it squared, is actually the root mean squared speed. If you want to know the average translation of kinetic energy over time, we replace it with the expression that we just established. Then we know that the average kinetic energy should be equal to this formula. Now, we substitute the expression of root mean squared speed and also this one. Then our average translational kinetic energy will become this one, right? Will become this one. Các bạn phải viết ra nhé, thì các bạn mới hiểu đấy, các bạn mới nhớ hơn. Am I right? And here, remember, this is actually Boltzmann constant, R over Na, okay? The gas constant over the Avogadro's number is actually called the Boltzmann constant. Then I can replace here. I have an interesting thing, because this one is a constant. Then we know that the kinetic energy, translation of kinetic energy, depends only on the temperature, right? Only one quantity, which is the temperature, will define the kinetic energy of our system. Translation of kinetic energy. And another thing, it applies for every gas. Every gas. It applies for every gas. Every gas is the same. So it depends only on the temperature for every gas. So at a given temperature, all gas molecules, no matter what their mass, have the same average translation of kinetic energy. Have the same translation of kinetic energy. This is a very interesting thing. Good. From now on, you know that the kinetic energy of a system depends only on the temperature of that system. And for every gas, it's the same. Every gas, it is the same. Is it okay? Good? Not too heavy? Not too heavy is good. I think I will continue to 1 or 2 more slides and then we stop. Now, have you ever heard about the mean free path? Mean free path. Here I have a picture. I have a lot of molecules. We know that molecules, okay, will move in any direction. Will move in any direction. And of course, it will collide to all the molecules. This one can move this, and this one can move this. How far each molecule, or how far one molecule can move before colliding with all the molecules? How far it can be. So this is the mean free path. The distance that one molecule can travel before colliding with others, we call it the mean free path. The average distance that one molecule can travel before colliding with other one. We call it the mean free path. I already explained it without using the slide. So the average distance traveled by a molecule between the collision. I have one molecule here. It can go this way, it can go that way, it can go this way, right? So for each direction, it may have a distance before it collides with all the molecules. Then the average of that distance, we call it the mean free path. Được không ạ? Tôi có một cái molecule ở đây nó chuyển động tất cả các hướng và nó sẽ va chạm với các nguyên tử khác, đúng không ạ? Thế thì cái quãng đường trung bình mà nó có thể chuyển động được trước khi nó va chạm với một cái phân tử khí khác, nó được gọi là mean free path. Free là tự do, path là đường, mean là trung bình. Okay. I don't know if we have time. Okay, let's see. Now I try to establish it once again, the expression of the mean free path, because I should do it very quick. Now I consider two molecules. Each molecule will have a diameter d, okay, and it will travel with a constant speed, and the other molecule is actually at rest. When it comes into contact, I mean when there's a collision, then we will have this case. This is when we have the collision. Then when the two molecules are into contact, what do we have? We will have a diameter of 2d, right? For both two molecules. Is it okay? Two molecules. So we can replace this, to simplify our question, we can replace this with only one molecule of square meter 2d, why I say square meter, I'm tired, of diameter 2d, right? During the collision, I can consider like that. Is it okay? All the conditions for the collision is unchanged. Is it okay until here? Good. This is only when it comes to the collision. Then what do I have? In the time delta t, okay, the moving molecules will strap out a cylinder of length v delta t. So that molecule will travel at a time of delta t. And because it has a diameter of 2d, okay, it travel at a time of delta t. So the distance is v delta t, am I right? And the volume that this molecule sweeps out is actually this one. Đúng không ạ? Đây ạ, cái quả cầu của tôi á là đường kính 2D đấy. Nó đi một quãng thời gian là delta t đấy, đúng không ạ? Thế thì cái quãng đường nó đi được là v delta t, đúng không ạ? Thế thì cái thể tích mà nó tạo ra được cái thằng của nợ này, nó tạo ra được này, thì nó có phải là đúng là thằng này không ạ? So the volume, so you know how to calculate the volume, right? Of a cylinder, which should be p pi d squared times this one, times the length. Good. Then the number of collisions that occur in time delta t, should be equal to the number of molecules that lie within this cylinder. Okay, the number of collisions that occurs in time delta t should be equal to the number of molecules that lie within this cylinder. Nó tạo ra một cái thể tích như thế này thì nó chỉ có thể va chạm được với những cái thằng phân tử nó nằm trong cái cylinder này, đúng không ạ? Làm sao mà nó đi ra được thằng khác và làm sao nó đi ra được cái thằng này trong cái khoảng thời gian delta t nó chỉ đi này thôi mà. Then the number of molecules in the cylinder is actually can be calculated using this formula. Good. Then the length, then the mean-free path is actually the length of path during the delta t, to the number of collisions in delta t. And it should be written like this one. Here, I just replace the length, okay, the length that the molecule travels during the delta t. And here the number of collisions that I already established here, the number of collisions. If I simplify this one, I will have this expression. I simplify this and I have this. But this one, is based on the assumption that all the molecules except one are at rest. But in reality, all the molecules are moving also. All the molecules are moving. So it changed in this one. It changes in this quantity, speed that I already cancel out. This one. Here, because I consider only one speed and others are at rest. But in fact, we should consider the relative speed between molecules. Not only the speed between one molecule who is at rest and one molecule who is moving. We should consider the relative speed. Okay? The relative speed. And remember the relative speed. Here we have the average speed of the molecules related to the container. And here we have the mean speed of the single molecule related to all the molecules. If you remember the relative speed of two random molecular velocity, the relative speed is actually this one. This one moves in this way, this one moves in this way. So we use a little bit mathematics. We can redraw the number 2 like this. So this one is actually the relative velocity. And we should be able to calculate it using a little bit of mathematics. I don't know if you already learned it. Here, the relative speed is actually can be calculated using this formula. Okay? Because this one equals 0. That's why we have that kind of formula you already know during the mechanics. Then, now if we consider the V1 equal V2, then the relative speed should be able to be written like this one. You replace it into our formula. If you replace it, we should have this final expression for the mean free path. I recommend you to redo it at home. You should be able to refine the expression for the mean free path. And I think we can stop here, otherwise the other lecturer will kill me. Thank you. If you have time, I invite you to redo, if you have time at home, of course, with the worker, I invite you to redo all the development to find the final expression. Thank you so much for today. So I hope you enjoyed it.